This video is over square root application problems, or as you guys like to call them, your very favorite thing in the whole wide world, word problems. The first one we're going to do is about pendulums. The period of a pendulum is the time it takes the pendulum to complete one back and forth swing. The period t in seconds can be modeled by t equals 1.11 square root of L, where L is the pendulum's length in feet. What is the period of a pendulum that is 10 feet long, and how long is a pendulum that has a period of 3 seconds? So we can solve this using a table and a graph, or we can solve this using algebra. So I'm going to start with an algebraic solution for this. We're going to just take the equation they gave us, and we'll use it to answer each question. Alright, so first question, what is the period, and remember period was t, so what is t, of a pendulum that is 10 feet long? So that means L is 10. We're going to just put a 10 right there. We're going to say t equals 1.11 square root of 10. And then that's something you would just punch into your calculator and round, and we get approximately 3.5, and it's in seconds, so 3.5 seconds. That's simple. Second question. So how long is a pendulum that has a period of 3 seconds? We're looking for the length now that has a period t of 3 seconds. So now we say 3 equals 1.11 square root of L. And we're going to have to work this problem backwards. And of course I didn't leave myself very much room, but what you would do is divide both sides by 1.11, and then you would square both sides. And you can do this in your calculator. You're going to get an L, which is a length of 7.3, about 7.3. And remember that's in feet, so 7.3 feet. Don't forget your units. So there's one answer and there's the other. So algebraically, that's pretty simple. We could also do this with a graph, though, if we wanted to. And so here's what happens if you put y equals 1.11 square root of x, because you have to use y and x instead of t and L, but it's the same thing, into your graphing calculator. It's going to have the curve like this. And so for the first question, it says when you're given x and you want to find y, all you have to do is hit second calc and then pick value. And you can enter in any x value you want. So in this case, you enter in a 10. And when you hit enter, it will give you the 3.5 that you were looking for. So it's kind of a cheater method, but that's okay. You can use your calculator. So that's right over here, 10, 3.5 up here, this point. Use blue. There we go, right there. Or if I give you y and you want to find x, unfortunately there's no second calc value for y. You have to actually enter the y value into y2. And it'll graph a line at that y value. And then you look for the x that occurs when those two things intersect. So you do second calc intersect, hit enter 3 times, and it'll show you that x is 7.3. So 7.3 feet, just like we did in the algebraic problem. And if you wanted to use a table for this, you could as well. When it showed you your x's and y's in the calculator, you would just look for, in the first case, you would look for a 10, and then you'd find the corresponding y, and it would be 3.5, or it's like 3.49 something, but it's harder to find the y value that you're looking for, because this isn't actually 7.3, it's like 7.3 something, something, something. So the table's not the best method to use when you're trying to find a y value. That's a whole number. You might not necessarily have them in your table that way. This next word problem is about a ladder. If an 8-foot ladder is leaned against a wall, the height of the ladder along the wall is given by h of x equals the square root of 64 minus x squared, where x is the distance along the floor from the base of the ladder to the wall. So let's draw that. Here's our ladder leaning up against a wall. H of x, that's h, that's the height. It's an 8-foot ladder, and x is the distance along the floor from here to here. All right. It says estimate the horizontal distance that the ladder should be placed from the wall, so find x in order for the ladder to reach 7 feet up off the floor. So we're going to plug a 7 in for the height, and we're going to find x. 7 equals 64 minus x squared, square root of that. So to undo a square root, we need to square both sides, and we get 49 equals 64 minus x squared. And then we can we can subtract 64 from 49. We're going to get negative 15 equals negative x squared. Or you could subtract 49 from 64 and add x squared to the other side. But either way, with them both being negative, we can then just divide by a negative 1. So we have x squared equals 15. And x equals plus or minus the square root of 15. However, we know that this is not a negative distance here, so we're going to eliminate the negative. And it's just the square root of 15, which since this is a real world thing and you wouldn't tell somebody to put the ladder a square root of 15 feet away from the wall, you would say approximately 3.87 feet. And when you're doing these word problems, it kind of helps because you can say, well, is that reasonable? Would I place a ladder almost 4 feet from the wall? And yeah, you would. So that's reasonable. It's logical. If you had gotten 50 feet, you would be like, no, that's not possible, and you would start over again. All right, now let's solve the next one. Figure out the height of the ladder. So now figure out h. If the ladder is placed 2.5 feet from the wall. So now if x is 2.5 feet, so 64 minus 2.5 squared. And this one's just a plug it straight into your calculator kind of problem, and you will get approximately 7.6 feet. And is that logical? Yes, an 8-foot ladder could lean about 7.6 feet up on the wall. So that's how you do that algebraically. Now, those of you who are visual, you can also do this in the calculator, graphing and looking at the table, so let's do that too. And if we graph it, we're just going to do the positive square root, and it's going to look like this. Now notice that I've only shown my window from 0 to positive and 0 to positive, and that's because I'm not going to put this ladder behind the wall and I'm not going to put it under the floor. So I don't need any negative x's and I don't need any negative y's. Alright, and then if we wanted to find, like the first part was when we wanted the x value. Ooh, there's the bell. Sorry to scare you. That means I need to go, but I'm almost done. If we enter a 2.5 in for x, and then it's going to tell us that y is 7.6, that's right there. And if you wanted it the other way around, you would graph y equals 7, find the intersection, it would give you an x value of 3.87. And so that's another way to solve this. You have two methods. And I am done, and the bell rings, so I need to get to class. Have a great evening.